And welcome back. I'm doing another sapf or sapf or sound as pure form stream. Basically picking up where we left off yesterday. And over on Blue Sky, James McCartney, the creator of sapf and also Super Collider, originally found my stream from yesterday and watched it and had some comments. So let's maybe start by looking at those. So this was one thing that I was talking about yesterday. I don't know why you are seeing the input code being echoed to the console output in the REPL. It should just print the stack after each input line. So yeah, something weird going on there. I mean, the printing might be partially something that Emacs is doing, specifically the comint mode, which is like interacting with command line executables. I'll have to look into that at some point. But even so, it's slower than I expect. Not sure what's going on there. But yeah, that's for another time. Then, oh yeah, yesterday I was wondering about this comma and dot syntax, which we found in the README here. Not this one. Yeah, I think that was this bit. So if a word is preceded by comma, the interpreter pops the object on top of the stack, looks up the value bound to the symbol in the object, and pushes that value onto the stack. So yeah, I was gonna say hypothesis, but it's not even that. It's just guess from yesterday was that these are some kind of like Lisp macro type of thing, quoting. But as James points out, they are for doing object lookups. And actually we came across that later when I was building, for example, this sound here and setting up this form or object to contain all these parameters and then accessing that via these methods. Then here I use the dot operator, and yeah, I guess the comma is like related, but yeah, rather than applying that value bound to the symbol, it just pushes it onto the stack. Okay, and yeah, in case you weren't here last night, so what I did basically at the end of the stream was create this little drone sound here. We can play it again. So this was a few... Oh, I should use play here actually. Yeah, it turns out there's a record function, so I can give it the signal, the file name to record, and then just say record, and then that gives me a recording, which is nice. But yeah, so this was just 5 pulse oscillators with a bunch of modulation on each of them. Filtering and pulse width modulation and a bit of detuning and such. Okay, but let's go back to the comments here. And yeah, James pointed out that there is a function called linlin, which I was looking for early in the stream, but couldn't find it. But then later on I did find that it's part of the prelude, which wasn't loaded at first. Then he mentions some other infinite sequence functions that I didn't know about. So we have natural numbers in both like list and signal versions. So I guess the convention here is that with a Z after the name, then that's like the signal version. Ords. And then this was interesting. So at some point I was looking for the min operator or function to get the minimum of 2 values, and that is called ampersand in sapf. And then for max we have the pipe. And you might know these also as and or operators from other languages. And so this was a bit confusing to me at first, like what's the relationship there? But if we think about it, let's say we're using ones and zeros to represent booleans, and we want to get the AND of these two. Well, it turns out that that is actually the minimum, right? Because if either of these is 0, then we should return 0, but if both are 1, then we should return 1, and that corresponds exactly to this behavior. And then, you know, pretty similarly for the pipe or operator, which behaves as maximum. The logic is pretty much the same. You can check it yourself if you don't believe me. There is a fade-in function. So I ended up implementing a fade-in myself last night in, I guess, kind of a hacky way, but not super hacky in the end. Where was it? Here. So it's basically just setting up lines like a multi-stage envelope, but then it goes from 0 to 1 over this duration, and then it goes from 1 to 1 over an infinite duration, so basically it stays at 1 forever. But yeah, let's see what fade-in says. So it takes an input signal and a fade time. Okay, so that's pretty similar to the fade function I ended up implementing in terms of behavior, at least. Then there's a hangz, which repeats the last value of a signal forever. So this was another interesting way to create that fade in. Let's look at line again. So, duration, start and end. So we go from 0 to 1 over 1 second, and then normally that's a finite signal, so if we multiply something else with that, then that multiplied signal also becomes finite, but that's not what I wanted yesterday. I wanted it to fade in and then keep playing indefinitely. So then hangz just keeps repeating the last value of that signal forever. So that's neat. Learned a bunch of new things, and there's more. You could concatenate a line with an infinite series of ones. So it seems like we have a function 1z, which returns a signal of n ones, and we could pass infinity to that. And then we have something called the dollar, and that appears to be the concatenation operator. Very good to know. And was impressed by how much I was able to figure out, and says my intuitions are very good. And thank you for that. I guess at this point, having worked with so many programming languages, some of which are directly, or some of which directly inspired sapf, I guess it makes sense to have some sort of intuition for these things. And also, sorry, also one thing that happens when you know a multitude of programming languages, and especially if they're in different paradigms, is you kind of become pretty good at just quickly starting to feel the vibe of a new programming language, so to speak, and then you can, like, based on that, guess how some things are gonna work. And then I asked a question which brings us to tonight's topic, which is if James could suggest any functions to look at for sequencing, because as regular viewers here might know, I like to make very sequenced music. And of course, James had a number of suggestions, so there's a few different functions for sequencing. You know what, let's actually copy the whole comment into here just so I don't have to jump back and forth. So, yeah, we have these functions, and then something which is very interesting to me as a big fan of SuperCollider 2 is that there is something that corresponds to SC2's spawn. And when I read this, my eyes lit up and, like, ideas started to go off in my brain. Because spawn is a very cool eugen in SC2, and it is what the entirety of my pattern system that I built for it is based on. Just a second. Right, so let's have a look at some of these. Actually, I guess we can split this into lines. And ask for help on all of these. Right, so these seek and iSeek are like trigger-based sequencing functions. So this is kind of like impulse sequencer in SC2, and I think there's an equivalent thing in SC3, but I forget what it's called. So they take an input value and a trigger signal, and I guess the input value is going to be either a list or maybe a signal works as well, but a list would make sense. And then for each trigger it pulls a value from that input. Well, the first question I have is, does it loop? And we have two variants of this. The first one, seek, seems like it sustains at the value that we get from the input, and then iSeek outputs that for just one sample, so it's like an impulse. and outside of that it just outputs 0. So let's see what we can build with this. Okay, maybe we should go through the other functions here as well. So imps. Single sample impulses. So you specify values and durations and a rate, and then I guess it just goes through those at the specified rate. Okay, steps. This doesn't say a whole lot, but I imagine it's like similar to this, but instead of impulses we have like sustained values. Then we have gates, which lets us also specify like hold times. And I'm gonna save this bit for later, even though it is maybe the juiciest part of this. Or yeah, I guess exactly because of that. So let's see. Let's make some kind of simple-ish example. What we could do is first of all make a sequence of just pitches and then give that to a sine oscillator. Do we have something that just produces impulses at a steady rate? Yeah, impulse. So, the way I would approach this is... Let's bring this into view again. So input and trigger. So let's set our input to, I don't know, some kind of arpeggio, for example. So we could go 0, 3, 7, 10. Then the trigger signal we would build. Let's say we have a frequency of 4, phase of 0, impulse. Then we can pass these things into seek. Let's call that frequency just for some clarity. Then we can do frequency phase 0 and put that into sine ask. And let's multiply that by 0.4 so it's not super loud. And finally play that. Okay, I keep making the same mistake I did yesterday, so these are now hertz values, which are very low. Let's try something like... Okay, if I have 0, then I can convert that to hertz like this, but that's also very low. Let's say we first add... I don't know, 36. So then we put that here, add 36 to everything in this sequence, convert to hertz, and then that should maybe work better. Okay, It was quite bassy. You might not have heard that if you don't have bass on your speakers. Let's go up to 60. So you can tell we have an arpeggiator. This answers my question from before, which is, does it loop? And it does not. So I imagine, given the overall focus here on like potentially infinite sequences, the way to make it loop is to, well, apply some kind of looping function to this list. Could it be called loop? No. What about cycle? Repeat? Let's have a look at the examples. Maybe they have something there. Okay, here's something called rand2s, but is that a built-in? Okay. Okay, here we see something interesting. There's psych. Okay, there we go. Makes a finite list become cyclic. I'm curious, what is mus? Puts a finite sequence into a random order, so it's like a shuffling function. I wonder where that name comes from. Well, anyway. So, basically all I need to do here now would be to put a psych here. Oh, and then we get an interesting warning. Binding a possibly infinite list at the top level can leak unbounded memory. Which makes sense, actually. So maybe let's not bind it at the top level and instead put it in a form like we did yesterday. So we have our output function, lambda o. Let me just check if there's something built in called arp. No. So we can put all of this in here. So that gives us our infinite arpeggio without the warning about leaking memory. Very nice. What else? Let's actually let's put this impulse train in its own field or key or whatever. It goes here, then what I would like to do is then have an envelope that is triggered on each impulse. So how do we do that? And there's now two ways to approach this, I guess. The way I'm working with here is where I have one infinite signal, so then in that case I would want to have an envelope that keeps re-triggering with new impulses. And the other way would be the spawn method, where you spawn like, I assume you spawn like individual signals that are finite, and then the envelope can also be like just triggered ones per each of those. At least that's how spawn could be used in C2. But yeah, I wonder how the other way could be done. Let's see. Decay 2, I think, was another envelope. This one actually takes a trigger input. Interesting. But I wonder, do we have that for like the arbitrarily shaped envelopes? Or even just for ADSR. Because yeah, this one doesn't take triggers from what I can tell. I'm thinking there's maybe like some idiom for doing this for all of these envelopes that I'm just missing right now. But maybe it doesn't matter. Maybe that's gonna be our segue into looking at OLA, or the spawning thing. So OLA stands for overlap add. This is the basic operator for polyphony. And we have arguments called sounds, hops, rate, num channels. For this one, I think it's probably better if we can find an example. There's a number of these, but I'm trying to just think which one could be the simplest. Maybe we'll try this one. So, okay, let's try playing it first so we hear what it's about. That's pretty cool. Okay, I think I'm gonna have to try and dissect this to see what's actually going on. So, the basic form of OLA is that it takes sounds, hops, rate, non-channels. So then I guess this one is non-channels, this one is rate, this is hops, and then everything here is sounds. Oh, hello, Babiolone. I would need some help understanding what is going on. I'm otherwise committed. Okay, sure. So what we're looking at is James McCartney's recently published audio programming language, which is named sapf, or Sound as Pure Form. You can find it on GitHub, lfnoise/sapf. It is Mac OS only right now, but maybe that'll change in the future. So yesterday I did a stream taking a first look at this, because like this was published the day before yesterday, or yesterday depending on your time zone, but anyway. So I did some basic exercises and just figuring out how the language works. Made a bit of a drone sound, and now we're looking at how to actually sequence things in this language. So, you know, melodies, rhythms, and such things. Now specifically I'm looking at this overlap add function, which seems very powerful, and I kinda just wanna figure out how it works. So I think my dissection here didn't quite work. I made some kind of mistake. Let me also clear the stack. Why Mac only though? I guess it's because James works on a Mac and he originally just made this for himself to play with and generously decided to open source it for all of us, so there is an issue on the GitHub about switching the audio playback library to RT audio, which is cross-platform, but Yeah. So, I'm still a bit confused about what went wrong here. You a developer too? Yes, I am. I mean, not a developer of this software, but I do all sorts of programming for, what is it, 23 years now. Recently focusing on audio stuff because that's just where I've ended up musically. Live coding and such. Right, so I need to check the help for this again. So we have sounds, hops, rate, non-channels. Let me do like a partial dissection first, so okay, so that still works, but now if I call this sounds, then for some reason we only hear that one voice and then it stops. I wonder what's up with that. Let's take a look at the stack at this point. Okay, here the stack is empty. So before Ola we have wait, I think I got it. So right, because this is a function, we're assigning it to sounds, then when I say sounds here, then it tries to call that function instead of putting just the function on the stack. So we need to put a backtick here. Yep, that fixes it. Okay, so then let's look at sounds. So this is a function that does a bunch of things. Hold on, what are parentheses actually for here? I think I missed something from the readme, or I just forgot about it. Right, so you can use them to bind multiple values from the stack, but that's only after a equals sign. here we are not after equal sign, so what's up with this? So rand takes 2 parameters. Like, I don't really see a reason why we would need parentheses here. Let me just try removing a couple of layers of parentheses to see if they actually do anything. I think they don't. Okay, so then maybe they are really just for like readability, a kind of comment. But you do still have to match them. Interesting. Just trying to see if there's any documentation about this. Aside from this bit about the like multiple value binding, but that's not what's happening here. Okay, for the time being, I'm gonna assume that there's just like a readability aid. Babylon says, I'll be back. Alright, thanks for joining. See you another time. Okay, I'm gonna restore the parentheses because I guess they are gonna help me understand what's going on here. So I guess the idea is that this is now like one thing on the stack. Then this is another, so we have a sign and an elf pulse. I wish my parenthesis matching worked here, but it seems it does not right now. That's something I'm gonna need to fix in the sapf.el that I wrote. So we have 2 oscillators on the stack here. Then we lag this one by 4m, which I think is 0.004. Yeah. And lag takes, I think, just 2 arguments, in and decay time. Then we multiply that by 4c, so this remains like one thing on the stack. Then we multiply these two together. Then we... What is rpen2? Could it be random panning? Oh yeah. Stereo pan at a fixed random position. And then finally we apply this quad envelope. Alright. So, this is starting to make sense, and indeed it is very similar to Spawn in Superglider 2. The one thing I see that might be different, I'm not sure, is that in SC2, the function that you pass to the spawn UGen gets as input or as an argument a reference to like the spawn itself, and it is able to set the rate or the time until the next event from within that function. But it might be that we don't need that here, because I imagine hops is gonna be like the interval between events, and then rate is just a way to like go faster through that, maybe. Okay, let's try to build our own example of this with some simpler oscillators, just so it's easier to find through trial and error what's going on. Do we have expand? Xrand. So we use this, we give that to the sine oscillator, we multiply by something like 0.4. Okay, let's try this out. So a little issue there. It is infinite, or each of those sine waves is infinite. So we end up stacking them indefinitely. So we need to make this finite. And I guess the way we do that is by multiplying with a finite envelope. Let's try the quad env, because it seems simple to use. It just takes one argument. Let's put 1 second as the duration, do a quad env and multiply. So that way we get already something. I don't quite understand the behavior of this envelope. Because it says 1 minus x to the power of 4, 4x from minus 1 to 1. Let's see, what does that actually give us? Why aren't my axes labeled? Like, I'm guessing this is -1. Okay, so it's like a symmetric envelope. So it's got both attack and release. But let's say I wanted something more plucky. For example, I think Decay was one of these. And then there was Decay 2 as well, so that one can have a bit of an attack time. Let's go with that one. Say 1 millisecond. And then just 1 for the Decay. Okay, I messed up something. Hold on. Alright, this one wants an input impulse. Maybe I can just put a 1 there. Sorry, that was a bit loud. Not entirely sure what happened there. Okay, I'm gonna try maybe another one. The line should be simple enough. So let's go from over 1 second, let's go from 1 to 0 and line. Okay, now the question is, can I make hops a list? Let's say I wanted to have half, quarter, quarter, and then I want that to repeat. Yep, that works. And this is cool. Now we can start to see the possibilities of sequencing melodies and rhythms and whatnot. I imagine that the sounds could be an array as well, or a list. So we could have different synths basically that we cycled through. Let's try that. But before that, let's maybe make a slightly more harmonic thing. So, because now it's just picking random frequencies, and that's not super nice for what I'm trying to do. Do we have a choose function? Pick, okay. And I think at this point, I again want to start structuring this as a form. So let's say we have something like, I'm going to use the same notes from that arpeggio from before. How did I write it? Like this. Then we're gonna have out. And all of this goes in there. And then you'll have to bear with me as I figure out the indentation manually here. Wait. Like this, I guess. Let's see if this works. I'm gonna call that melody. So something like this. Okay, that's pretty good. The envelope is a bit clicky, but I'm not gonna worry about that for now. And then I think I also want to put some random panning on this. Oh, but I have to set non-channels to 2 here. Okay, then let's say I actually want to have this start at a lower octave, but then I want it to how do I say this? I want it to include 2 octaves of notes that it picks from randomly. And I think we can do that with something like, if we have, for example, the list here, then We can duplicate that with AA, then we could concatenate them. But before concatenating, we want to add 12 to the second one, and that's how I get 2 octaves. So now if I play this, yeah, that's how we get it switching or like picking from different octaves. What about if I wanted to have 3 octaves? Then I think I can just repeat the AA12 plus and add another concatenation. Yeah. And we could vary the decay of each of these notes. Makes it a little bit more interesting, I think. But let's go back to what I was talking about before, which is making multiple different synth voices that we can cycle through. Just gonna copy paste that one, but then do something different here. For example, a pulse wave. I'm gonna make these notes a little longer. Just a moment. Let's add a filter here. So that would be something like... random cutoff and Q there. I wonder if hops could be a function as well. Let's try that. So instead of this list here, we would have something like this. No, it looks like we only get the half notes. What if I put the function in a list and cycle through that? Okay, then we get nothing. Oh, I'm making the same mistake again. Now that it's a function, I need to put the backtick in front, and then maybe it'll work. No. No, I think I broke the interpreter. Let's try again. Okay, yeah, that actually just breaks it. So maybe this is not possible then. But I do wonder if there's a way we could make an infinite list where each element is generated by calling a function. That would kind of solve the same problem. What if I did something like... Okay, I'm gonna pull this out of here and experiment a little. So my idea is that I have this function with a list. I make it cyclic, however you pronounce that. And then for each element I apply the function which is that element. Okay, yeah, this seems promising. It feels a bit hacky, but I don't know what would be the more idiomatic way right now, at least. So let's try that. So now we have a bit of a randomized rhythm where each note is either half note or quarter note. Okay, what else can we do with this? Okay, what if instead each of these elements is a list, and then we flatten that, and why? You'll see why in a moment. Not yet, just confirming that this works. But now we can do a thing like... three consecutive sixth notes. I think maybe I want to do two of these also to keep the rhythm synchronized. This is actually really interesting that you can do this in such an easy way with this like infinite list processing. I've often wanted something like this in Tidal and Superglider, but sometimes it can be a bit annoying to set up. One thing you'll notice here is that my different synths have a bit of repetition going on. So ideally what I want to do is make something else than sounds. First we want to make a list of oscillators. And to each oscillator I want to apply this function where I do the random panning and the envelope. And then I should be able to get rid of these bits. Let's see if that works. Yep. And also we could factor out the frequency. So let's say we get that as an argument in both of these cases. Then we can just do this. Maybe now I want to declick these envelopes, so I'm gonna do like 2 milliseconds of fade in. Maybe that's not enough. Okay. Let's say I then wanna add a delay. This was delay time, max delay time, decay time. It's a bit too fast, actually. kind of want to do a thing where it's not always delaying every note. But rather so that it's randomly picking notes to which the delay should be added. And this, I think, gets a little tricky because now we have to... Basically, we have to find a way to control this input signal from within here somehow. What if... Here we return, in addition to this signal, a second value, and it'll be either 0 or 1, depending on whether we want this note to be delayed or not. But does that work? No, because this goes straight into the output of Ola, but I think there is a way to do this still. Maybe. So I'm thinking instead of a stereo signal, I'm going to return a 3-channel signal, and then the third channel contains the information about whether or not the stereo channels should be fed into the delay or not. How can I do that? Oh, hello, Germ45. What is the programming language? This is sapf, or Sound as Pure Form, a recently published audio programming language by James McCartney. Hello, Bliggs. You have a very interesting setup. Oh, you mean the hardware or the Emacs or what? Oh, hey, Fellhouse Audio. Super cool to see sapf in action. Yeah, it's a pretty interesting language. I'm really enjoying it, and now that I'm getting into the sequencing, I'm really starting to see like vast possibilities that you could do with this. I hear there is MIDI control. I don't know about OSC, but with those things, I could really turn this into a performance system. It seems difficult. Well, depends how comfortable you are with like audio digital signal processing and also these stack-based languages, because this is a stack-based language, so the syntax is a little weird compared to traditional programming languages. Oh, the hardware. Right. Yeah, I talked about that before on stream, but I have here the Moonlander keyboard. I have the MIDI Fighter Twister as MIDI controller. I have this Winry 315 macro pad, which is programmed to be a MIDI controller with QMK firmware. We can turn on the lights here as well. Then I have another keyboard here, just because sometimes I'm operating multiple computers at once. Anyway. Okay, I think I can do this like this. So I set the num channels to 4. Then from here, this would return just the stereo signal. Then I duplicate that. And then I multiply the second copy of that signal with either 0 or 1, randomly picked. And then I concatenate those two stereo signals into one 4-channel signal. And so now I guess we get dry left, dry right. Then we get effects input left and effects input right. So then I put dry left and dry right here. And instead of dry, I now feed FX in left and FX in right into the delay. And maybe that'll work. I don't hear anything. Interpreter still running. Okay, interesting. I don't know what went wrong there. Let's try to print the stack at the end of each oscillator. And that's a bit too fast for me to follow, so let's stop it. Wait, so it looks like we actually have a mono signal and then another mono signal. That doesn't make sense. Let me just check my assumptions here. So if we have something like a sine oscillator and I do random panning to that, that would give us a stereo signal, which is a list of 2 signals, right? Yeah, that's what I expect. But instead we have something else. Also, we have an error here. B is not a sequence real. Yeah, I think that's when we're trying to do this unpacking here, where that kind of errors out. Which it would if the stack looks like this, but why does it look like this? That's what I don't understand. Okay, let's comment out this bit for the moment. return this to, well, no, let's keep it. Okay, now we actually hear something as well. So the stack at this point is a stereo signal. Okay, that makes sense. But it doesn't do the thing I want, so we're still only halfway there. Victory. Yeah, it's a bit early for that. Oh, I see what I did wrong. I forgot to multiply the duplicated copy of the signal with this 0 or 1. So I think this should be correct. Yeah, that works. So you can hear now maybe that the delay only takes effect on some of the notes. Also, I think I might wanna maybe filter the delay input a little. So let's go HPF, add something like 250. Yeah, I'm pretty happy with that. I actually got a lot further than I expected so far. But yeah, I'm really growing to like this language and the way it lets me hack things. There's a distinct flavor of SuperCollider 2 in here, which, as some of you know, I like very much. We don't have client-server separation or synth defs that we need to care about. It's just evaluating functions and building synths. That sounds cool. I can't quite grok the syntax yet. My brain isn't used to postfix notation, but the sequencing looks more title-like and maybe more expressive than the sequencing in SuperCollider. I wouldn't say it's title-like necessarily. It doesn't have the same notion of cycles and dividing them into units of time depending on how many things you have in your list. I do feel it's more SuperCollider-ish than anything, and specifically SuperCollider 2, with the way this OLA or overlap add function works very similarly to the spawn UGen from SC2. And as for the syntax, I mean, yeah, that's what I was saying yesterday, that maybe the largest problem with postfix languages is that the code is unreadable. Well, I shouldn't say that. It's hard to read. You get better at it once you practice and you know the arities of all the functions you're using. And also, we do have the option of putting in parentheses to aid readability. So for example, we could say this. So this kind of logically groups these three things together and tells us that, okay, this is one item on the stack. Then this is an item on the stack, and so on. Let me just double check that that actually works. Interesting, that's helpful. Yeah, though it is entirely dependent on the programmer actually doing it. But yeah, I like stack-based languages for reasons I don't think I can necessarily explain. It's just like a weird liking to this really quite simple model of computation. Like you push things onto the stack, you apply functions, they pop things off the stack and push new things on the stack, and that kind of thing. There's just a certain elegance to it. And definitely the fourth experience that I gained from hacking on open firmware helps here a lot. So, I don't know if I have anything else I want to go through tonight. I'm just gonna make it a bit of a shorter stream tonight. Actually, I don't know how long I've been going for. Let me check that. Yeah, just short of 2 hours so far, so. But that's good. I don't always have to do long streams. Okay. I'm gonna leave it at that. I hope this has been interesting and inspiring. If you're interested in learning more of the basics of sapf, then what you can do is read the README, or you can watch my stream from yesterday where I started basically from zero. But that's like 3 hours, so it might be a more effective use of your time to read the README and the examples, of course. But yeah, for example, with these examples, I find that I have to often copy them and start dissecting them and seeing what is grouped in what ways, and yeah. Some of these are very well laid out. So for example, here we have comments explaining what every line does and that kind of thing. But yeah, that's gonna be it. Thank you for joining me tonight. Like, subscribe, press all the buttons, buy my album to support me. Yeah. I feel like I had something more I wanted to say, but I can't remember it anymore, so I'm just gonna accept that it was not that important. But I will see you on another stream, and yeah. Have a good rest of the weekend. Bye bye.